Exercise 185, page 466, question number 11. This particular question, to find the electrostatic potential on the circular disc, V is given by this integral between 0 and 9. So what we need to do is to let U be something convenient and see if that can make things simpler. If I look at it, if I let U equal R squared plus R squared and differentiate that, then I'll get a 2R term, 2 times capital R, which should cancel out this capital R at the top here. So that's the way to proceed, and also to rewrite the square root as to the power minus a half, because it's underneath, it's inverted as well. So have a go and see if you can do it. You could pause at each step and see if you can carry on as I go through the solution. So the first thing I would do here would be to rewrite the integral as 2 pi sigma integral between 0 and 9 of R times R squared plus R squared to the minus a half dr. And then I would let U equal R squared plus R squared and differentiate with respect to capital R. And that would give me 2R. So rearranging, dr equals du over 2R. And so now we can put in our information into the original integral. And we get V equals 2 pi sigma integral between 0 and 9 of R times U to the minus a half times du over 2R. So the R's cancel as we want, and also notice the 2's cancel, so we can actually end up with this. V equals pi sigma integral between 0 and 9 of U to the minus a half du. And that's a standard integral. Add 1 to the power, divide by the new power. V equals pi sigma U to the half over a half between 0 and 9. Again, dividing by half is the same as multiplying by 2, which can come outside the integral. So V equals 2 pi sigma U to the half between 0 and 9. And again, we could either change the limits by replacing R with 9 and then 0, or we can put U back in with what it was before. So using that method, which is the one I normally use actually, so V turns out to equal 2 pi sigma. What's U? It's R squared plus R squared. So this is the square root of R squared plus R squared between 0 and 9. So putting this information in, we get V equals 2 pi sigma. Putting the top limit in first, so R is 9, so this will be the square root of 9 squared plus R squared. Minus, putting the bottom limit in, the square root of R squared, which is 0 plus R squared, so that just leaves us R squared. And tidying up, 2 pi sigma leaves the square root of 9 squared plus R squared minus R, because the square root of R squared is just R.